today I'm going to be talking to you about the value or importance of research and development. And we're basically over here at the moment doing outreach with some of the universities here, Peradeniya, Moratuwa in particular, to develop some collaborative research networks and that sort of thing. Okay, so a bit of an overview of what we're looking to cover today. I'll start with a little bit of an introduction to cover what it is that we're looking to do as far as R&D is concerned, some of the R&D values, why you should be looking to do this sort of thing within your organisations. And then I'm also going to use some case studies to try and provide some real-world examples to help you benefit your understanding and that sort of thing. And looking at some of the current research activity that we're doing at SingleView, and maybe some Q&A at the end. And basically the goal today is really to convince you of the value of research and development, how you can use this to drive innovation, get you to think about how you can do this within your own organisations, the kind of strategies that you can look to implement and that sort of thing as well. One thing I should also point out as well, this is very much a sort of beginning level introduction to R&D, so it'll be nice and gentle and hopefully something that will be easy enough to pick up and follow as we go along. Okay, so we'll start with a little bit of an introduction. As I said, I really want to try and use some examples to try and assist understanding and that sort of thing as well. So I'll provide a little bit of background about SingleView and myself as well. And again, this will help provide some context that should helpfully improve or help you work with the case studies and examples that I'm going to use to try and articulate what I'm talking about. In this section, I'll also provide a very basic overview of the scientific method as well, which essentially your body of techniques that you use to investigate phenomena, acquire new knowledge, correcting and investigating previous knowledge, that sort of thing as well. Okay, so we'll start talk a little bit about SingleView International. As you've probably seen from the banner behind me, we're one of the platinum sponsors here this year, so it's very good to be involved. We've got offices in Colombo, here in Sri Lanka. We've also got offices in Australia, headquarters in Perth, which is on the west coast of Western Australia. We've also got offices in the US, in New York as well. And we specialise, SingleView specialises in the design and development of data-driven software solutions. So again, our involvement with this conference and the people here is very much a good fit and a good match. We have a big emphasis on open source technology as well. We're a Java house. We've got partnerships with MongoDB, Red Hat, those sort of guys as well. And we also like to involve our developers in terms of letting them have a lot of freedom in terms of what they choose to go with as far as our technology stack's concerned. So our technology stack is quite cutting edge and quite up to date as well. Our primary business is in the education market, particularly the kindergarten to tertiary sector, and we develop data-driven enterprise scale level software solutions for that particular market, but we also have interests in the healthcare and resources sectors as well. Anywhere really that you can see a data-driven software system having value and application are areas we're interested in. And we're quite progressive in terms of what we want to do, particularly within the education space. We really want to try and give teachers and educators and schools the tools that they need to really push education forward, move beyond outmoded concepts and paradigms, and really put the student at the forefront in terms of who the software is designed to serve first and foremost. Again, we want to look to try to transition away from this historically outdated instructor-led sort of role as far as a classroom management is concerned. We're much more interested in seeing the teacher as a facilitator and self-directed learning, personalised learning, these kind of things as well. Part of this also involves recognising the learner and each student as an individual with their own respective strengths and weaknesses. So as I'm talking about this sort of thing, you can probably see how a sort of data-driven approach, and in particular collecting as much information about the students' interactions with their teachers and their peers and the guardians and the parents as well, is something that allows you a lot of power in terms of working out these sort of things and providing evidence-based platform for decision-making and that sort of thing as well. I'll just scroll to the next slide. Myself, I'm the research and innovation lead at Singleview, so I'm lucky enough to be the head of research and development there, which gives me a lot of leeway in terms of investigating the kind of things that we like to do. I've got a background, I've got a PhD in educational technology, which I got from Edith Cowan University in Perth in Western Australia. I've also got a background in software development and applied research as well. So I've done some stuff with the mining industry in Australia. I've also done some work in the defence industry involving the Royal Australian Navy and their Collins-class submarine fleet. And in that particular context, that was looking at 3D graphical simulations and how these can be used to develop skills for real-world expertise. So if you consider, for example, if you've ever been inside a submarine, it's a very cramped space where navigation is difficult, and what they really wanted to be able to do was develop a software application that they could give to their trainee submariners and help them work out how to navigate the environment in the most efficient manner. And so that was one area where software can be used to satisfy real-world problems without actually having the trainees be able to spend all that amount of time within the actual environment that's being used all the time. So let's now have a look at the scientific method. Again, this diagram is just a sort of one size or one particular way that you can go about doing this, but this is the kind of underlying process that we use to drive stuff at Singleview. So if we break down and have a look at each of the individual stages, typically you start by posing a question or identifying a particular problem, and ideally this needs to be something that's articulated and as well defined as possible. And again, ideally it wants to be something where the scope is very narrow and specific, if you follow. From here, the next stage is always to start to look and see what other people have done in this particular area beforehand. So this is where you start to look at previous literature, previous reports, what have other people done before. There's no point reinventing the wheel. You want to be able to learn from other people's mistakes as well as their triumphs as well. So that's always a good basis for determining whether your problem has been solved before or whether it's worth pursuing further from that point as well. So things like Google Scholar is very much your friend in this regard at this point. From here, you want to move on to the hypothesis stage where you're looking to predict the outcome of the problem or an explanation for it that is informed by the information that you've elicited from the previous step. After this, you look at starting to prepare a suitable method for testing your hypothesis. And at this point, you can then move on to actually conduct your experiment, which involves typically the collection of data, often involving participants. You also, at this point, starting to look what kind of research methodology you're looking to instantiate, looking at qualitative methods, quantitative methods. Am I concentrating on mostly information that I'm eliciting from face-to-face interaction from people, or am I looking at a more statistical driven approach? Or, as I like to do a lot of the time, combine the two and go for a sort of triangulated approach, so combining multiple sources of information and cross-referencing them with each other in order to improve your understanding of the thing that you're trying to investigate. One other thing I'd point out here, when you obviously move on to the collection of data, particularly when you're working face-to-face with people using qualitative methods, you need to watch out for investigator bias and things like that as well. If you're trying to elicit information from subject matter experts, for instance, you need to be very careful about the questions that you pose to them so that you're not exposing your own bias, you're not asking them leading questions. You want the information that you get from them to be as pure and untainted as possible, if there is such a thing. Once you've collected all your information, that's when you can start to move on to the analysis phase. And this is where you're looking for patterns, insight, trends in the data. And again, as I said before, if you've got multiple sources of information, you can look to triangulate and cross-reference this information between the two of them. You might find, for example, one particular source of information is leading you in one direction, but you've got multiple other sources of information which are contradicting that. And that's, again, why it's good to have multiple sources of information. So that's a method that's often referred to as triangulation. And so once you've done your analysis, that's when you can then move on to conclusions and identifying some findings that are supported by the data. And from there, you then start to think about areas of future research. What impact have I had, or what impact has this study had? And this whole process is a cyclical and ongoing process insofar as we'd come from here and we'd feed back and continue the loop. But one thing I should point out that underpins this whole process, particularly within the commercial sector, is you'll always need to be thinking about how you're going to commercialise this entire process in terms of the findings that you arrive at, and you want to work out how these findings can either go towards ending up as features in your products or improving your internal processes or something like this as well. So there always needs to be a commercial underpinning or a business case that supports this entire process. You don't want to be going through all of this and the time and expense that's involved if it doesn't help you improve what you're trying to do within your respective organisations. So that being the case, we can now move on and start to talk about why you should be thinking about research and development in the first place. And this is something that within your respective organisations, everyone can really sort of think about, even if you're not actively involved or you don't necessarily have a background within a research context. It's certainly something that everybody within an organisation can contribute to, particularly as far as idea generation and that sort of thing is concerned. So I'll provide some examples here as well as we work our way through. So again, if you look at the research literature and the reports and the statistics and all that sort of thing, businesses that perform research and development are far more likely to record growth in terms of their sales and profitability and that sort of thing. One thing that you need to bear in mind when you're talking about research and development is that the benefits accrue over the long term. You can have short-term R&D projects and that sort of thing with a quick sort of turnaround, but generally it's something that is more sort of medium to long-term in terms of the time it takes to actually go through the process and have the findings, and as I said before, turn those findings into features within your products or improvements in your internal processes and that sort of thing. So I mean, essentially R&D is one of the means by which businesses can experience future growth through the development of new products, new services, improving your internal processes, and it's a way that you can go about improving and expanding your operations. And ideally, this is something that you want to use to provide an evidence base for identifying new discoveries that can lead to the development of new products, new services, that kind of thing as well. As we determined on the previous slide where we talked about the scientific method, this is something that should be cyclical and ongoing and continuous and that sort of thing as well. And as I also said before, it's also something that needs to be supported by a valid business case or a valid commercial reason for engaging with it in the first place. So it's, for that reason, it's generally not a bad idea if your R&D personnel have some sort of background or understanding as far as developing business cases, financial derivatives and what underpins it and that sort of thing. So we can't really talk about R&D without talking about innovation. Innovation's a buzzword that's everywhere at the moment. And in a nutshell, you can really think about innovation as being the products of your research and development. So you go through your research and development process, you identify findings, and your innovation is where you actually go about improving your products or your services and that kind of thing, and it's informed by the research and development that you do within your particular organisations. And just to talk about the value of innovation that's been talked about lots and lots in recent times, there's obviously a causal link between innovation and performance measures like productivity, and OECD estimates suggest that as much as 50% of economic growth in member nations can be attributed to innovations within businesses as well as governments as well. So as we covered in the previous slide, innovation that's informed by R&D is something that you would use to improve your products, your processes, the offerings of your solutions as well, but also not forgetting that innovation is something that you can use to improve and extend your internal processes as well, how your different departments within your organisation, your different personnel interact and engage with each other too. So for that reason, innovation in particular, you need to have a combination of top-down innovation, which is your sort of opportunities that coincide with your business goals and increase profits, in addition to bottom-up innovation, which is where your ideas come in relation to improving efficiency, workflows, processes, and that kind of thing as well. Your approach should be data-driven, evidence-based, hence the overlap with R&D. And as far as the social motivation for innovation, it's something that you need to make sure that the decision-making process in terms of which ideas that are put forth are acted upon, this needs to be transparent and openly communicated as well, and that helps to keep people engaged in the process. So if you've got people within your organisation coming up with ideas and contributing things, if for whatever reason you decide not to use their ideas, you need to be open and honest with them and say to them, look, we appreciate what you're doing, but we've decided not to choose to implement your idea for this sort of reason. So that keeps people motivated and engaged in the process. And again, if you look at the research around innovation, you'll actually find that it's the social and personal drivers that encourage people to participate in the innovation process, not so much the tangible sort of rewards and that sort of thing. So if you can keep that feedback loop open, if you can keep people feeling like they're engaged in the process, then they're going to be much more likely to feel that they've invested in the process and that they're willing to contribute ideas as well. One thing I should also add as well is generally it's a nice idea too if you can continue to involve the people that contribute ideas to the ongoing development of those ideas as well, so they become invested in the process and it becomes their baby. Again, it's all about social drivers and motivation as far as ideation is concerned. So we talked a couple of slides ago, or I had a point up on the screen a couple of slides ago talking about using both internal and external collaboration when your research and development is concerned. So your internal collaboration, this obviously covers your different people within your own organisations working on a particular R&D project or goal or activity or what have you. But another source for external R&D collaboration, it's something that we're very keen on and is something that again has been shown to be highly beneficial for industry in general, is collaboration with the university or higher education research sector as well. Just to provide some context about the way it is in Australia at the moment, there's a very heavy push at the moment to see greater collaboration between the industry and research sectors in Australia, which is something that traditionally we've not done very well for a number of reasons. There's been a number of reports that have been released by different institutions within Australia, and one thing that they did notice that in Australia we have something like only 43 or thereabouts % of people with PhDs, for example, that go into industry. When you compare that to other countries such as South Korea and Israel, they're much more higher. They're sort of in the 80% plus region. So in Australia, there's this sort of, not stigma, but this perception that needs to be got around, both as far as industry and the actual students are concerned and academia, in terms of opening up these pathways between industry and universities to work together to achieve some outcomes. And part of that as well is also the students themselves needing to sort of come to the realisation that they do have something to offer to industry. They've got transferable skills that they've developed and honed over the course of a PhD or a master's or what have you, and these can be directly tied to industry if they know what they're doing. So again, as I said, at SingleView we're very have a very great emphasis on close alignment with the university sector. Our Perth office is actually situated right on the edge of a university campus, so that works out really well for us. It allows us to just walk over the road when we want to do collaborative research and that sort of thing as well. But beyond that, it also, the networks that you develop with these institutions also open up a lot of other options for you in terms of internship programs, whether they're undergraduate or postgraduate, identifying recruits that are capable and bringing them into your organisation without going through the hassle of doing an exhaustive search to try and find someone to satisfy a particular role. So this is something that's worked really well for us, and look, in Australia, and something that we've come, as I said before, to try and replicate here with our Colombo-based office. We find that particularly if you have people within a higher education institution like a university, if they can recommend someone to you, that's worth its weight in gold in terms of saving you the time and the money than going out and looking for someone using a more traditional way. It also opens up other opportunities for you as far as programs, industry programs that universities are trying to push at the moment. And I'll give you an example of one we participated in this year with one of the universities in Perth, and that was a program where there's 5 universities in Perth. They all combined together, and students who'd submitted their PhDs and were waiting for their feedback to be returned, they were all formed into teams and placed in specific partner industry businesses, and they were tasked with solving a particular problem. So we got involved with this particular program. We had our team of 5 near completed PhD students, and we asked them to solve a particular problem. And just having a fresh, new perspective on the particular problem that we wanted to solve is invaluable. And what we did, we made sure that we embedded them in our Perth office. We made sure we embedded them as part of the team. They turned up every day as if they were members of the actual rest of the team based in the Perth office. And I mean, it was very much a win-win scenario insofar as the students really got a lot out of it. And one of the things they took out of it, I think that was most interesting, was that they came to realise that they had something to offer to industry, and not just with a PhD, not just academia, and just seeing the light turn on inside their head, and they realise I do have transferable skills. I can go out and solve problems that aren't within my immediate field of expertise, was a highly valuable process. So as far as our involvement in the program was concerned, it was very, very valuable, and something that we're going to continue to be involved with moving forward. Beyond that as well, again, involving yourself with universities, you also obviously gain outside access to talent that you might not have internally, fresh perspectives, new ideas, that sort of thing, and collaborative research grants as well, which can be a very cost-effective way of diversifying the risk that's traditionally associated with R&D, particularly if it's a larger problem that you're looking to solve. So I talked before about there needing to be a valid business case to underpin your R&D projects within your organisations. The other thing we should mention here as well is you want your R&D to be translated into features that actually end up in your products. As I mentioned before, it's not something that we want to do just for its own sake. We want to make sure that there's a tangible outcome, as it were, at the end. So, as I said, you can have your own sort of internal research programs, or you can look to partner with external organisations, but the principle remains the same. There always needs to be some sort of feature or process or improvement or a new product offering or something like that that is really the end goal for this particular process. So I suppose the way you can consider that is there needs to be a D in R&D for the development side of things. One thing that we've found has been very beneficial to us is being able to utilise our relationships with our clients to provide participants and subject matter experts to participate in our research and development programs. So we have a client in Australia. They're a large district of schools, and they've provided teachers, they've provided us students, they've provided us subject matter experts, and really like a lot of the research and development we've done in the past within that particular domain would not have been possible in terms of gaining access to those particular resources. So by all means, if you have that kind of relationship with your clients and your customers, and you can develop them to the point where they're actively involved in your product development process and can provide you with expertise and participants and data for your research, I mean, that's definitely a fantastic thing to do as well. And again, as it is with the external involvement with universities, this needs to be a win-win relationship. You need to offer something to them as well so that they gain something out of it as well. So as far as that example is concerned, the teachers that we've involved in our research in the past, they've got a lot out of it in terms of professional development, learning new things about themselves, gaining new skills, that sort of thing as well. Something I should also mention here as well, as far as the way that we do R&D at Singleview, we like to involve graduates in the process as well, even if they're not necessarily have a research background or anything like that. Just having access to fresh ideas and fresh perspectives and that sort of inquiring mindset is something that's highly, highly valuable. And one other thing I should mention here as well is, again, as far as your collaborations with your external universities are concerned, we're very open as far as publishing findings of research and that sort of thing as well. And this is good not only as far as developing our own credibility and reputation as thought leaders, but it's also something that the university research staff themselves are very interested and very keen to do. So this is something that if you wish to establish these partnerships, you're going to need to do as well. Okay, so with that background in place, we can start to sort of provide some examples now, now that we've sort of got an idea of the context of what we do and the people we work with and that sort of thing as well. So we're actually working on a new software product at the moment called Virtuoso, and it's a enterprise level instructional support platform for the kindergarten to tertiary education space. So a lot of the features that have gone into Virtuoso have been informed by R&D projects. Some have been, some are ongoing, some are still in process, some have been completed. But with this particular software platform, as I said before, we're very data driven. We're very sort of big on the idea of collecting as much information about the interaction of the users as possible. So part of that, as far as this particular software product is concerned, is really on the emphasis of recognising and analysing individual learning differences and appreciating each student as an individual with their own respective strengths and weaknesses and that kind of thing, really sort of providing an underlying software platform that supports more personalised approaches to learning and that sort of thing. And as I said there, it's heavily informed by research and development, and just to provide some examples, we've got some social network analysis features in here that are all driven by research. We've got some predictive analysis, educational mining, analytics, that kind of thing. We'll talk about that as we go through, but we'll provide a couple of case study examples here just to sort of illustrate the way that the process works, and again how you take something that's an R&D project and turn it into features within your product. Look at a first example here to demonstrate the pipeline, beginning with inception and moving all the way through to a tangible product feature. I should mention with this particular example that this is still very much an ongoing process. It's cyclical, it's iterative. We want to continue to improve our feature set. So again, the R&D process continues to roll around in a cyclical fashion. And at the moment, with this particular example, we're at the stage where we've gone back to involve our clients again and getting them to provide a second round of participants and subject matter experts so that we can further refine the features of this particular product in a way that will benefit them as well as us. Okay, so first thing we really did as far as this example is concerned, we recognised that there was a problem as far as teachers being able to look at something like an instructional statement. And when I say an instructional statement, I mean something like a learning outcome, an assessment task, a learning task, something like that. You all would have been exposed to these sort of instructional statements at school or university or college or what have you. So to provide an example of a typical sort of learning outcome would be evaluate the reliability and usefulness of primary and secondary sources. So, I mean, that particular learning outcome is only 8 or 9 words long, but there's a lot of information that's actually packed into that. So teachers, in order to be able to assist them to develop their understanding and get a better awareness of each of these learning outcomes that they're teaching to their students, we wanted to provide a way of breaking down these sort of learning outcomes into their sort of components in a way that will provide them greater understanding. And not only that, but doing it in a way where it could be informed by automated software processes so that we could really take the difficult work out of doing that for them. So as far as this particular project was concerned, again, this is something we did in collaboration with University in Perth, Edith Cowan University. And as per our scientific method diagram we saw way back in the beginning of the presentation, first phase after you identify your problem is always looking at the research literature to see what have other people done in this area, what can I learn from what they've done and that sort of thing as well. So from here we came up with basically a taxonomy matrix. And what this is, this really has 2 dimensions. If you look along this side, you've got different types of knowledge, and if you look along sort of the horizontal bit at the front, you've got different types of cognitive processes. And the way you can think about this is a given instructional statement, so whether it's a learning task, an assessment task, or a learning outcome, you can plot its position in one or more cells on this particular matrix. Each of the labels on the matrix have a sort of descriptive identifier which helps the teachers understand what types of cognitive processes and types of knowledge are actually involved with this. And as, I'm not sure if it's very visible on the diagram there, but this is actually hierarchical in the sense that The types of knowledge at the lower end here are less complex and less difficult than the types of knowledge as we're graduating up towards the back there, and much the same with the different types of cognitive processes. So if you look, the lowest level of cognitive process is just remembering something. On the flip side, the most complicated kind of thing is actually creating something new or discovering something or finding something. And again, this is something that's been synthesized from the literature. There's nothing really new about this. It's well understood. But going to the research literature and finding something that could act as a conceptual underpinning for our software implementation was very, very important. It would be no good developing a perfectly valid and functional software system for automatically classifying these kind of things if the underlying conceptual basis was flawed or invalid for whatever reason. So if we look at the next slide here, we can see that's the same matrix, just sort of represented as a flat two-dimensional structure. And basically the way it works is if we have a example learning outcome here, develop a narrative about the past, what we do is we deconstruct that. We look at verbs for this particular dimension in terms of the cognitive processes, and we look at nouns this way for the particular row or type of knowledge that's involved for the particular learning outcome involved. And what we're essentially doing here is we're determining a classification. So we can unpack this, we can deconstruct it, and we can determine that we're using creative cognitive processes and we're using conceptual knowledge, and when you arrive at a classification like this. Now, unless you've got a background as a teacher or something like this, this particular process is going to be alien to you. And even if you do, doing this manually is very time consuming. So in an ideal world, teachers would love to be able to look at each of the learning outcomes that they teach and break them down like this and really go, well, okay, these are the types of things that are actually involved with this learning outcome, but they just don't have the time or the resources or necessarily even the expertise to do this. So again, this was why we identified this as an issue and wanted to come up with a sort of automated software system for classifying these kind of things for them and repeating this process. So as far as our software implementation was concerned, we used natural language processing techniques. I talked on the previous slide about looking at the types of verbs and nouns that were involved in breaking down a statement into its individual components. And if you've ever had any experience with natural language processing before, you'll know that systems are quite good at this point at identifying the nouns and verbs and isolating them, tokenizing them, that kind of thing within a given statement. So again, well understood existing systems that we could tap into here. Our actual implementation relied on the Natural Language Toolkit and Python, and then we used a Java wrapper to get that in and working with the rest of our system. One thing I should point out as well that I've neglected to mention before is thinking about patents nice and early when you're doing your research and development is always a good idea as well. We've got a patent process underway as far as this is concerned. Any of you that sort of have gone down that road before will probably know that it can be a quite long and drawn out and expensive process. So it's often a good idea to think about this as early as possible so that you're not sort of caught out and you're not missing any competitive advantage because you're delayed for too long and that kind of thing. So again, as I mentioned before, as far as the research component underpinning this was concerned, we developed our automated approach for classifying the instructional statements in much the same way as a human did, and then we went and we continued the research and we started to look at, okay, well, how does the classifications that the automated system compare to those that a human would provide? And again, this is part of the research project that's ongoing, and it's very interesting to look at the ways that a human will go about classifying something and think about it, and they're much more subjective. They take different approaches depending on their particular backgrounds, and the next challenge for us is going to be refining the system further based on the feedback that they provide to really sort of look at the semantic and contextual nature to really try and tap into that. So that's going to be a challenge for us, but I mean, you do this thing in stages and it's very much a gently approach. Yeah, so I pretty much just covered that there. So I suppose to summarize that particular example, again, you're really sort of following the scientific method. You're starting by identifying a problem. This problem is contextualized in terms of what your clients need or what your solution offering would be improved by in terms of satisfying that particular problem. Looking at the research that has been done before you to work out, has someone else solved this problem? What approaches have worked in the past? What approaches haven't worked? How can we use that as a basis and go on to develop our own implementation? And again, then going through the process, coming up with a prototype or a proof of concept or something like that, and then going through and having a rigorous method for testing it involving subject matter experts and a well-defined, clear methodology that can be validated and stand up to scrutiny as well. Part of this as well, as I mentioned before, as far as your research and development is concerned, you want to try and spawn publications out of this process wherever it's possible. And we've done that as well. It's something that enables you to build credibility. It keeps your university partners happy. It gives you opportunities for networking and exposing what you're doing when you go to conferences or journals or that kind of thing as well. So it really is something that it's a multifaceted or multi-pronged approach. And I should say it's also something that's very much an integrated effort insofar as there being input from multiple departments. So you'll have your research and development, you'll have your business analysts, you'll have your software developers, everybody contributing to take this sort of thing from inception all the way to a fully realized and completed product. So I'll move on now. Let's look at a second example. And this time, what we're looking at here is really sort of determining approaches to better support educational leaders who will be using our products in terms of making informed decisions and determining how best to allocate resources and that kind of thing. If you can imagine within a school, if you're a principal or someone who's at the higher echelons in terms of the decision-making process, there's a lot of different things you need to consider in terms of where you're allocating your resources, who you're hiring, evaluating which teachers may be performing well, how each individual student doing within the context of the school, all that sort of thing as well. So, I mean, if we look at the expectations that school leaders face in the 21st century, they've really got a lot of different things that they have to juggle. There's a lot of problems they have to resolve, and the expectations heaped upon them are continuing to increase. So they really need to be able to demonstrate the ability to successfully educate a broad range of students, each with their own individual and different needs, competing needs as it were as well. They're also expected to steadily improve achievement for all students as well, irrespective of their backgrounds and strengths or weaknesses as well. And not only this, they've obviously got to do this in a financially viable manner as well. They have very finite resources available to them from which to achieve their particular outcomes and do or complete continued improvement as well. So just to provide some of the things that they really are lumped with as far as being leaders in a 21st century schooling environment, as I said before, we're really asking them to be able to identify and accommodate the capabilities and characteristics of each student within their school. They're expected to be able to create learning experiences that cater to these individual needs. They need to provide meaningful opportunities for student collaboration. They need to be able to identify and respond to students who may be experiencing difficulties or having problems in some way. They're expected to provide professional development opportunities for their teaching staff, identify those that need continued development and improve them and find out the ones that are doing really well and use them as mentors to bring the other ones, the junior teachers, up to speed. So really they've got a lot of different things that they've got to manage, their school finances, collating and analysing all this information. So essentially we're really asking them to do more with less. And one of the things that we asked ourselves was what features can we implement within our products that would better assist school leaders in particular to better achieve the outcomes that they've identified in an efficient and financially viable manner. So as a starting point, we sort of said, well, what does the existing research tell us about the most successful school systems on a global perspective. One such source of information that's very, very helpful in this regard is the OECD Program for International Student Assessment. And essentially what this program does is it compares the performance of 15-year-old students in mathematics, science and reading in all the OECD member nations, and I think probably another dozen or 15 more on top of that. So it really gives you a global snapshot of where each individual education system within each country sits compared to their peers, where their relative strengths and weaknesses lie. And I mean, this is a really useful resource for us because it allowed us to, well, examine in greater detail which systems were performing at the top of the tier and perhaps those that weren't performing at the bottom compared to their contemporaries. And using this, analysing this information and working out, okay, well, how can we use this to improve the solution that we're offering to schools around the world. So just to provide an indication of some of the findings from the PISA data, they recommend that you want to target low performance regardless of student socioeconomic background to really bring those that aren't performing well up to the standard of those that are. So it's really about equitable opportunity and access to education and being able to identify those that may not be performing that well and allocating resources to them intelligently to bring them up to the level and in doing so raise the overall level as well. And I mean, these are consistent with findings from other sources within the literature as well. And from this, it sort of follows that you want to be able to provide your school leaders and your schools and your teachers with the information that allows them to identify students at different levels, schools at different levels, and be able to make informed decisions about where they allocate resources, what they're looking to do, that sort of thing. As far as our particular application was concerned, as I said on the previous slide, what we determined was that we wanted to support the decision-making process within the Virtuoso software application. So really what we're talking about here is data-driven decision-making, collecting all this vast quantities of information about student, teachers, parents, administrators' interaction, and taking it and analysing it and presenting it to them in a way that they actually can make use of it. It's no good if you're able to take all this information and you can't present it to the end users in a way that they can actually use to achieve the outcomes that they want to achieve. So as a case in point, one of the things that we came up with within Virtuoso was this concept of student individual education plans. And in a nutshell, what that actually involved was looking at all the information we've captured about a particular student, working out where they're performing well, where they're not performing well, and collating and presenting this information to their teachers in a way that allows them to actually chart an improvement plan, measure progress, look at milestones, that sort of thing as well. And I mean, again, this is something that is well recognised within the educational fraternity. It's just that it's too much of an administrative burden to do this for 30 or however many more students you may have in a class. So in looking at this, we have the opportunity with data-driven software solutions to automate a lot of this hard work and just concentrate on providing the evidence-based information to the teachers that they can use to improve everybody's educational outcomes. Okay, so we're getting towards the end now. I'll just quickly run over some of the current projects that we're working on at SingleView. Virtual and augmented reality, something that's obviously got a lot of value and potential as far as providing learning opportunities for students, particularly around things such as immersion, presence, spatial relations, that sort of thing as well. Things that we're really interested in there is multi-user interaction, how if you had a classroom of 20 or 30 students all within the same virtual reality environment, what could you learn as a teacher or instructor from looking at their interaction? What can you learn about their behaviour? Who's learning what? That sort of thing. So opportunities for assessment. And that's when you start to look at things like computer vision, machine learning, these kind of things as well, in terms of identifying this information and presenting it to the teachers in a way that is usable and accessible. I mentioned before, we've got a very big emphasis on individual differences and understanding each student as an individual, personalised learning as well. So again, as I mentioned, our approach is very much one in which we try to capture as much information about the student's interaction within the system as possible, because that gives you a much richer base from which to perform your data mining, your predictive analysis, that kind of thing as well. And this feeds into the concept I talked about a moment ago with your student individual education plans, your IEPs. I mentioned before that this is something that's well recognised as being a value within the sort of educational domain. In the US, for example, it's usually used for students who are identified as being gifted or those that are acknowledged as having learning difficulties. But our approach was very much one in which we wanted to provide personalised learning plans for all the students within the system. So again, we're really leveraging on the affordances of what modern software applications can do in terms of streamlining the analysis, taking away that administrative burden, and really just providing the teachers with the information they need to make informed decisions and that sort of thing. Following on from that, we've also got a very real interest in psychometrics, and psychometrics are essentially the measurement of psychological characteristics. So if we start to think about students in terms of their underlying psychological characteristics, such as their cognitive functioning, their affective characteristics or their emotional characteristics as they relate to their schooling, what we're interested in doing is coming up with an assessment tool, a software-driven assessment tool that can be deployed within the platform and administered en masse, so that we can collect this information about all the different students and feed this in and develop a richer sort of profile of each individual student. And currently this is something that's traditionally done. If you have a psychometric test, it's normally you and a registered psychologist sitting on either side of a table, and that's the process that we go through. So we have an ongoing research effort that's committed towards working out a way of distilling the important elements of this process and instantiating it within the software so that we can do it for all students within a school, not just those who have access to a registered psychologist. So, I mean, that information obviously provides you a wealth of opportunities for, again, your data analysis, your predictive analysis, your data mining, that sort of thing as well. Educational data mining is obviously a huge one. We have an enterprise system which collects large quantities of data. So those of you with a background in data science or data mining and that kind of thing, you can see once you have information about, say, even a school system involving, say, 50 different schools within a given geographical area. If you're able to collect information about every facet of student, teacher, parent interaction, that gives you so much opportunities as far as identifying trends and insights in the data and that sort of thing as well. And one of the things that we're very interested in building into our products and have built into Virtuoso at the moment is this concept of predictive analysis. So being able to predict with a variable degree of statistical significance what a given student, or how a given student, should I say, is going to perform within a given subject. And if they're in danger of not, say, performing very well, we can kick off alerts and notifications and inform their teachers and say, well, look, there's a, 80% statistical chance that this student's not going to pass this unit. Let's come up with an intervention or a strategy to improve or make sure that this negative outcome doesn't come to pass before it actually does. So again, you're providing them with the evidence-based information to allow them to intervene before negative outcomes come to pass. Another area we've got a very real interest in is 360-degree video assessment. So as you can see with the picture there, grab 10 GoPro cameras, stitch them on a 3D printed head and place that in the middle of the classroom, and it gives you a 360-degree uninterrupted view of every facet and component of student-teacher interaction within a classroom. And again, the wealth of information that this provides you when you start to combine it with other sources of information really gives you a lot of insight into behavioural analysis, assessment techniques, professional development. How is this teacher reacting to a particular situation? How can we take video that's been captured for, say, a very well-acknowledged teacher within a school and use this to bring maybe underperforming teachers or new teachers up to a higher level based on self-reflection and that sort of thing as well. And finally, we've got also an interest in seeing how that overlaps with student health and well-being, looking at the relationship between nutrition, physical activity and academic performance. And I mean, this is where you can start to look at things like wearable technologies, and data-driven solutions have a very big role to play here as well. So again, we've got a very active research interest in looking at measuring dietary intake within schools, measuring level of physical activity within schools, and seeing how this information correlates with academic performance as well. And again, this is something that's very well supported within previous research that's been done in this area. There's a very clear relationship between these three things. And again, with modern software solutions, we're in a position now where we can provide these features within a product with the end goal of improving educational outcomes and improving outcomes for our clients as well. So, in conclusion, we've provided a sort of very basic overview of the sort of research and development process. And as I said at the beginning, what I really wanted to do was try and provide some worked and detailed examples which would sort of demonstrate the way the pipeline works and the way that it can be built into your internal processes within different organisations. So, I mean, there's always a consistent pattern here. It's always about clearly articulating a problem, and it's always a problem that has relevance to your particular solution offering or improving things for your clients or your customers, that kind of thing. You're always going to be looking at what others have done in the area, and then from here you then go about establishing a robust and well-validated methodology to find the information that you need to solve this problem before you then go about developing a particular proof of concept or software solution that satisfies it. And as I said before, it's very much an iterative and ongoing process as well. There's always room for improvement, so it just keeps going around and around and around. And this is really what you use to drive innovation within your organisations in terms of improving your product offerings or coming up with new product offerings or improving your internal processes and that sort of thing. So yes, R&D is a long-term game. It's crucial for long-term growth and profitability. If you're not in the process of looking for ways to innovate your product offerings and even yourselves as organisations, you're at continual risk of being disrupted by those that do. So I mean, this is also something that you can use to distinguish yourselves from your competitors, irrespective of how large they may be or how many resources they have in comparison to yourselves. Make use of not only internal but external collaborations. Look to involve people within your organisations who have different backgrounds, different perspectives. They don't need to necessarily have expertise or experience within the research domain. What you really want to tap into particularly is their ideas and developing a process so that they feel comfortable in contributing those ideas to the benefit of the business as a whole. Beyond that, you also want to look at external collaborations to gain access to outside expertise, leverage opportunities for growing your networks, recruitment, collaborative research grants, that sort of thing as well. There is a very clear and obvious relationship between research and development, innovation and commercialisation. And as I stressed at the beginning, there needs to always be a solid business case that underpins the entire process. We don't want to be investing time and resources in R&D that bears no fruit from a business or commercial perspective. And probably lastly, I would say, look to recruit individuals who have that sort of inquiring mindset or passion for attempting to answer the unknown or challenging them with problems and that sort of thing as well, because they're people that you can definitely look to involve in the R&D process. Okay, so I've only got a few minutes left. Were there any questions at all? Yeah, it is, definitely. But I mean, what we like to do is try and have multiple projects on the go simultaneously, and then you'll typically see one start to come to fruition as others are ongoing. So you can see continual tangible benefits becoming realised as you go through. But you're dead right, it is very much a long-term game. And if you go in with that mentality from the onset, then I think that's the best way to go about it. With your IP stuff, yeah, that can be, particularly as I'm sure you know, when you're starting to talk about patent, especially as far as software is concerned, it can be very challenging. So as I mentioned before, it's the sort of patents and an IP and that kind of thing is something you want to think about early on in the process. And I mentioned I went out to the University of Peradeniya on Wednesday and talking to one of the senior lecturers there, and he was saying that what they're starting to do is actually involve or starting to teach the sort of patenting IP stuff as part of their software engineering undergrad process, and I think that's a very good way of going about it, so that by the time these guys graduate, they're already starting to think about, how can I protect the intellect, or what is the best way that I can go about improving my chances of improving my intellectual property that I might generate for the businesses that I go to work for once I've graduated. The other challenge probably within that area is coming up with an IP arrangement with your external collaborators, so your universities, and that's something again that you want to sort of get out the way nice and early so that everybody's happy, having a nice, well articulated and detailed intellectual property agreement between the university and yourself, so that there's no issues that come to pass further down the track. But I agree with you, it's definitely a challenge. Okay, if there's no more questions, I've got 3 minutes to spare, so thanks guys, and yeah.